Hey everyone, it is Miss Marnick. We are looking at factors or multiples could be problems. These are word problems where they will tell you one number that you know and it will say could be in it. If you see one number and the hint could be, it usually means that you're going to try to solve it by thinking about factors or multiples. So you can use this box up here as a guide to help you. If you only know the total, then that's a hint to use what you know about factors. Sometimes, though, you might only know how many are in each group. And if that's what you know, then you're going to want to use what you know about multiples. So we know factors are the numbers that multiply together. And we know that multiples are counting by the number. So we can use what we know about those to solve these problems. So this first part are all going to be factors could be problems, and you're going to use a factor strategy to help you with 1 and 2. So let's take a look at number 1. The classroom has 24 kids in it. If the kids are in equal rows, how many kids could be in each row? Just like any word problem we do, the first thing we're going to do is bracket the question. How many kids could be in each row? A big hint in this problem is could be. If you see could be, it means there's more than one correct answer. It's great when we get multiple choice when we have a could be problem, because then we can just test out these choices. We don't have to test every single possible number that it could be. So multiple choice makes it nice for these types of problems. It also says in each row. That is labeled IEG for in each group, and we don't know how many are in each group. We do know 24 kids. That's the one number they give us. 24 kids is the total number of kids that are going to be sitting in the rows. The rows are our groups, and we don't have a number for that. So we do have a number for total. We don't know groups or in each group, and it's could be. So with one number and could be, we can use our box to help us. So we know the total is 24. So we're going to use what we know about factors. So I'm going to put an F here so I know I'm using a strategy about factors. I know that factors are the numbers that multiply together. So I'm looking for something times something equals my total. And my total is 24. So 24 is going to go in this end spot right here. This is when it's really, really nice that we have multiple choice, because my first number, my blank, I can test out A, B, C, or D and find out blank times something, that's what I'm trying to solve, will get me to 24. So I have a missing multiplication problem here. I can use the inverse operation of division to check. So when I'm checking, I'm always going to start with my total for division, divided by blank equals blank. So let's start actually testing these out. So for A, I need to know if 7 times something equals 24. Missing multiplication means I can divide 24 divided by 7. I can use my calculator. 24 divided by 7 equals, and I get 3.428571429. I only need the first 2 decimals to know it's a decimal and not a whole number. So I'll cut it off at the 2 and put 3.42. Since that's not a whole number, I know A isn't going to work. So I'm going to cross it out and keep on testing. Next, I need to know 5 times something equals 24. Without even using my calculator, I know right away this isn't going to work, because I know the trick for 5s. All multiples of 5 end in 5 or 0, and 24 ends in a 4. So without even using my calculator, I'm going to cross that one out. I know that it doesn't work. So now I'm going to test 8. 8 times something equals 24. I can do 24 divided by 8 equals, I can use my calculator, maybe I just know. My calculator says it's 3. So this is a whole number, so it could be this one. I'm pretty sure it is, but I just want to test D, 9, to make sure I didn't make any mistakes. So one more time, 9 times something equals 24. And I can do 24 divided by 9 equals, use my calculator, and I get 2.666666, a bunch of sixes, and then it ends in a 7. So I'm going to cut it off at the first two decimal points, 2.66. That is not a whole number, so it can't be D. So I know my answer has to be C. There could be 8 kids in each row. Let's do the same strategy for number 7. The movie theater has 56 seats in it. If each row has equal amounts of seats, how many people could be in each row? So I'm going to bracket the question first. How many people could be in each row? I see could be. I know that that means there's more than one answer, but I see that I have multiple choice here. So I can use those to test it out, so I don't have to test out every single number. I see in each row. I know that is IEG for in each group. I see the number 56 seats. That is the total number of seats that the movie theater has. And we're talking about rows again, if each row has equal amounts of seats. The rows are my groups. So once again, I know the total. I have one number that I know, and it's a could be problem. I don't know my groups. I don't know in each group. So if you know the total, use what you know about factors. So I'm going to put an F here so I know I'm using a factors strategy. I know factors are the numbers that multiply together. So I'm going to test blank, and my blank comes from one of my multiple choice here, times something equals my total. And I know my total is 56. This is missing multiplication. I can use my inverse operation to check. Inverse of multiplication is division. So I can take my total, division always starts with total, divided by blank equals blank to solve. And I'll put 56 in here because that's what I'll be dividing. So now I can check. I need to ask myself, 9 times something equals 56. Missing multiplication, I'm going to do division to check. 56 divided by 9 equals, use my calculator, 56 divided by 9, 6.222222. I'm just going to cut it off at 2, 6.22. Show my evidence, but 6.22 is not a whole number, so this is not going to work. Cross out A. B, 10. So I need to ask myself, 10 times something equals 56. Now I know for 10, all multiples of 10 end in 0. 56 ends in a 6, so I know that's not going to work without even using my calculator. So I'll cross that one out. Next, I'll check C. 4 times something equals 56. Do division to check. 56 divided by 4 equals 56 divided by 4. Ooh, 14. I get a whole number. So if I have a whole number, I know that's probably going to be the right answer. So I'll star C. But let me just check D6 to know for sure. 6 times something equals 56. Do the inverse operation, 56 divided by 6. Plug it into your calculator. 9 point, a bunch of 3's. So 9.33, not a whole number, cross it out. I know C has to be my answer. How many people could be in each row? There could be 4 people in each row. Okay, number 3 and 4 are multiples could be problems. So we know we're going to use a strategy for multiples. If we look back up at our box, if we know how many are in each group, that's how we know it's going to be multiples. So let's take a look at number 3. The sandbox has 8-pound bags of sand in it. How many pounds of sand could be in the sandbox? First, bracket your question. How many pounds of sand could be in the sandbox? Box in could be. This tells me there's more than one answer, but I have a nice multiple choice list to test, so I don't have to test every single number. Let's see, I see 8-pound bags of sand. So I have to picture in my head all of these bags with 8 pounds of sand in it. So 8-pound bags, there's 8 pounds in each group or in each bag. So I know, the only number I know is how many are in each group. I don't have a total and I don't have a groups. So this means I'm gonna need to use what I know about multiples to solve this. So I'll put my little M here to remind me. I know multiples are counting by the number. In this problem, I'm counting by the number 8. So I need to ask myself, how many times can I count by 8 to hopefully get blank? So for A, I'm asking myself, how many times can I count by 8 to hopefully get 38? This is missing multiplication, so I can do division to check. 38 divided by 8 equals 38 divided by 8. I get 4.75. That is not a whole number, so it can't be A. Now let's check B. How many times can I count by 8 to hopefully get 96? Do division, 96 divided by 8 equals, oops, not 9 divided by 8, 96 divided by 8. Ooh, that's 12. That's a whole number. So I'm guessing it's going to be B, but I just want to check C and D to make sure and double check that I didn't make any mistakes. So for C, how many times can I count by 8 to hopefully get 60? 60 divided by 8, 7.5. Not a whole number. Oh, let me write 60 divided by 8 equals 7.5. So I have my evidence. Cross out C, that's not going to work. Last one. How many times can I count by 8 to hopefully get 65? So my division is 65 divided by 8. 65 divided by 8 equals 8.125. So 8.12, not a whole number. My answer has to be B. There could be 96 pounds of sand in the sandbox. Let's try out number 4. The truck has 7-pound bags of gravel in it. How many pounds of gravel could be in the truck? Bracket the question. How many pounds of gravel could be in the truck? Box in could be. This means there's more than one right answer, but I have this multiple choice list so I can test these out. I do know the number 7-pound bags. That means there's 7 pounds of gravel in each bag. So this is going to be labeled as in each group. Looking at my box, if I know how many are in each group, I'm going to use what I know about multiples. I don't have any other numbers. I don't know my groups. I don't know my total. So this is going to be a multiples strategy. I know multiples are counting by the number, and I'm counting by the number 7. So I need to ask myself, how many times can I count by 7 to hopefully get blank? And in this blank, I can test out my answer. So for A, how many times can I count by 7 to hopefully get 92? If I do 92 divided by 7, check that with my calculator, I get 13.14. Not a whole number, can't be A. Let me check B. How many times can I count by 7 to hopefully get 77? Inverse operation, 77 divided by 7 equals 77 divided by 7. I get 11, which is a whole number, could be B. Let me check C and D just to be safe. How many times can I count by 7 to hopefully get 51? 51 divided by 7 equals 7.28. Not a whole number. Doesn't work. Let me check D. How many times can I count by 7 to hopefully get 60? Inverse operation, 60 divided by 7 equals 8.57, again, not a whole number, can't be it. There's only one it could be, and that is B, 77. There could be 77 pounds of gravel in the truck. Okay, we're on the back. We're looking at mixed could be problems. So these problems could either be factors or multiples. You have to decide which strategy that it could be. So I showed you how to set up each type of strategy on the front of this. So if you're still confused about how to set it up, go there on the back to watch how I do it. Then here, you can just come to check your work because I'm gonna go a little bit faster. I'm not gonna check each one, and you're gonna need evidence to show your work. So make sure you're just using this to check your work and using it to get you thinking about where the problem's gonna go. So number 5, there are 46 stickers in a book. If each page has the same amount of stickers on it, how many stickers could be on each page? I bracket the question. How many stickers could be on each page? I see could be, so I know there's more than one right answer. Good thing there's multiple choice to give me a few to test out. Let's see, I see 46 stickers is my total. My pages are how many groups I have, and I want to know how many are on each page or in each group. So if I know the total and I don't know anything else, and it's a could be problem, I know I'm going to use a factor strategy. So I'm asking myself, blank times blank equals my total, which is 46. I want to know what two numbers can I multiply by to get 46. Now one of the numbers, the first blank, I can use one of my choices, but I need to figure out which number would go in this blank here. Since it's missing multiplication, I can do the inverse operation of division to solve. So 46 divided by blank, my number that's in my choices, equals something to get my answer. So for A, I would do 46 divided by 7 equals, when you type that in your calculator, you're going to get 6.57. It's not a whole number, so it can't be that. If you check B, you will get 5.75, which is also not a whole number. If you check C, 2, you know that 2 times something could work for 46 because all multiples of 2 end in 0, 2, 4, 6, or 8. So you know that it could work. And then if you also check your calculator, your evidence would be 23. So could be C here. D, if you check 9, you're going to get 5.11, not a whole number. So you know your answer has to be C. There could be 2 stickers on each page. Let's try number 6. There are 4 pictures on each page of my album. How many pictures could there be in the entire album? Bracket the question. How many pictures could there be? This means there's more than one right answer, but I can use my multiple choice to help me check. And let's see, there's 4 pictures on each page. So 4 pictures in each group, or IEG. That's the only number I know. It's how many are in each group. So I'm going to use multiples to help me figure it out. I know multiples are counting by the number, and I'm counting by the number 4. So I need to ask myself, how many times can I count by 4 to hopefully get blank? And I can put one of my answers in my blank. So for 99, I would do 99 divided by 4. If you check that in your calculator, you get 24.75, which is not a whole number, so that doesn't work. If you check B, your evidence is 11.5. That doesn't work. If you check C, your evidence is 23.5. That's not a whole number, so that doesn't work. If you check D, your evidence is 17. That is a whole number, so that's the only one that can work. So that means there could be 68 stickers in the album. If there's, oh, not stickers, sorry, pictures, because there's 4 pictures on each page. Let's try 7. A church has 42 available seats. If each row has the same amount of people in them, how many people could be in each row? Bracket the question. This is a could be problem, so I'm going to use these multiple choice to help me check. I know in each row stands for in each group, and it doesn't have a number that goes with it. I see 42 available seats. I know that's my total amount of seats. So I know right away, I know the number for the total. So this is going to be a factor strategy since it could be, and I only know one number. I know factors are the numbers that multiply together. So I'm going to write blank times blank equals, and I want it to equal my total, which is 42. Since this is multiple choice, I can put one of these numbers in the first blank, but I have to figure out what this number is. That blank times something equals 42. I can use the inverse operation of division to check, so that would be total comes first, divided by blank equals blank, and 42. So to check A, I would have to do 42 divided by 9. If you do that, you're going to get 4.66. That is not a whole number, so cross it out. For B, if you check, you get 10.5, not a whole number, cross that out. For C, you get 6, that is a whole number. So, oops, that could work, hang on, but let me check D, I might have circled too early. D is 5, and I know right away 5 isn't gonna work because 5 times something can't equal 42, because all multiples of 5 have to end in 5 or 0. So without even using my calculator, I can just cross out D, and phew, I was right. The answer is going to be C. There could be 7 people in each row. Number 8. There are 3 cars in each garage. How many cars could there be in the neighborhood? Bracket the question. How many cars could there be? More than one correct answer, so I'll use my multiple choice to test. The only number I know is 3 cars in each garage or in each group. So I know how many are in each group. I don't know any other numbers, and this is a could be problem. So if I know in each garage or in each group, I'm going to use the multiple strategy. Multiples are counting by the number, and I'm counting by the number 3. So I need to ask myself, how many times can I count by 3 to hopefully get blank, and I can use these blanks in here. So for missing multiplication problems, I can do division to check. So for A, I'm going to do 73 divided by 3. If you plug that in your calculator, you'll get 24.33, which is not a whole number, can't be A. For B, if you check that, you'll get 28. That is a whole number, could be B, but I still have to check C and D. C, you would get 30.67, not a whole number, cross it out. For D, you would get 20.33. Again, it's not a whole number, it can't be D, so it has to be B. So there could be 84 cars in the neighborhood. All right, last one. I have 96 rubber bands. If I make loop bracelets with the same amount of rubber bands for each one and use up all the rubber bands, how many rubber bands could be in each bracelet? Bracket the question. How many rubber bands could be in each bracelet? Put a box around could be. There could be more than one answer, so I'm going to use these multiple choices to help me. I see in each bracelet, that's in each group, which I don't know. I know 96 rubber bands, I know that is my total. So if I know the total, and it's a could be problem, and that's the only number I know, I'm going to use factors to help me solve. So factors are the numbers that multiply together. So I need to know blank times blank equals my total, which is 96. I know I can use these for the blank times some other number to get 96. So this is missing multiplication. I can do the inverse operation of division to check. Division always starts with the total, which is 96, divided by something equals something. So let's look at A. I can do 96 divided by my blank, which is 7. If I do that, I get 13.71. Not a whole number, I can cross that out. If I test 6, my evidence is 16. That does work, so it's probably B. For 5, I know right away 5 isn't going to work because 96 ends in a 6. All multiples of 5 end in 5 or 0, so I can cross that one out right away. And now I just have to test 9. 96 divided by 9 equals 10.66. Again, not a whole number, so it has to be B. So there could be 6 rubber bands in each bracelet. All right, that is your factors, multiples, could be homework. I will see you tomorrow to check it.